Okay, now we want to talk about a concept called the central limit theorem. So suppose I want to ask people, how much do you agree that psychology is the best major in the universe? From 1, nah, to 5, absolutely. Right? And suppose we want to know how people in this school think. In this school means Dublin and you, okay? Uh, the population is about 3,700, yeah, give or take. Uh, okay, so suppose for some reason we already know that the population mean is 3. So in other words, um, the whole school, in WMU, on average, answer to this question, they give the number 3. All right. Usually we don't know. We have no idea what the true population mean is, but let's assume we know. Now, I want you to imagine that we can randomly take a sample of people, get their average score, put them back to the population, and then take another random sample, and so on and so forth. Do that for 9 times. Imagine we can do that. We cannot do that, but imagine we can. Okay. And by the way, this is called sampling with a replacement. All right. So the population mean mu is 3. Uh, and this is how it looks like. So this is the population. And the first time, let's say we take 4 people, right? And calculate the mean and put it back. And then second time, 4 people, calculate the mean, put it back, and so on and so forth for 9 times. The first time you see is 3. Hey, it is the same with the population mean. But the second time is 2. Third time is 4. 3, 1, 4, 3, 5, 2. Well, as you can see, it's not every time will be 3, right? And that's easy to imagine because population is quite diverse. Sometimes we got some extreme scores, right? So not necessarily we will get 3 every time. However, we also can imagine that most of the time we'll get a mean around 3 because the true mean is 3, right? So you know what? Actually, from those numbers, we can make a distribution. With see, this is the distribution, and this is quite normal, don't you think? The mean will be around 3, right? Um, Now, this distribution, we call it the distribution of means. Okay, and they have some. This distribution has some interesting, how do you say, qualities. Okay, first, it's more normally distributed than the population itself, and second, less variation. In other words, it's more narrow, like this. So, if this is the population, and then we do the distribution of means, we'll see this distribution of means, this blue one, is more narrow and looks more normal. Okay. Now this distribution, if we can know some information about this distribution of means, it will be useful for us. As for example, we can calculate confidence interval, which I will cover later. Um, However, the problem is, in reality, it's pretty much impossible for us to go out and do collect data information like this, right? Repeat the process. Usually we just do it one time. So how do we know the property or the information of this distribution? Well, those are very smart statisticians. They I don't know how they do that, but they figured out a way. Okay, so they tell us first, the mean of this distribution, and by the way, the symbol of this mean is called mu sub m. Okay, so let's say the mean of this distribution is the same as the mean of the population. And of course, this is very easy to understand because the symbol is from the population, right? Second, the standard deviation of this distribution, by the way, the symbol is a sigma sub m. Right? And how do you calculate the standard deviation of this distribution? And statisticians say don't worry. According to our professional opinion, this is the formula. Yeah. Now, you notice that this is actually population's standard deviation. And they say actually the standard deviation of this distribution is this function of a sample size because you use some population's standard deviation and divide it by the square root of sample size. Okay, but now we need to give a name to this standard deviation because every time you need to revert it to the standard deviation of the distribution of meat. That's a long name, right? So let's give it another name, call it standard error.